I'm hoping that this video is quite a bit shorter than the last one. The last one ran for the full 30 minutes that I can record, but I am going to hop out of order from the curriculum that I'm using to create these videos and cover division properties of exponents. And we're only going to cover them in part, and then we're going to go back and cover what it means for an exponent to be 0 or for an exponent to be negative. But I think that 0 and negative exponents are a lot easier to get your head around if we cover the division properties first. So as with the multiplication properties, I want the division properties to make sense to you. I want you to be able to go back and derive those properties yourself if you needed to. And so for there's basically just like one division property that we'll look at, and then the second one is a variation on a multiplication property. But let's take a look at, we're going to do, not that, I don't know what it is about. We're going to do 2 to the 5th over 2 to the 3rd. Okay, so we're looking at division, and when we're looking at the division, what we're looking at are dividing like bases. So hopefully you remember from the last lesson that the base here would be the 2 and the exponent is the 5. And by definition, what that means is in the numerator, we have 2 times itself, 5 times there. And then in the denominator, we can expand it out. And again, this is employing the definition of what an exponent is. If you understand what that exponent means, then it gives you so much power to write and rewrite these expressions. Now, notice this here, okay? And this entails that you understand a little bit about the fractions here. But we've got 2 over 2 times 2 over 2 times 2 over 2, and then there's like these 2 extra 2's there. So essentially what I did, and I'll kind of go through this, is I'm grouping these 2's, okay? Look at them. Like that. Okay, and what we know is that 2 over 2 is equal to 1. So essentially, this is 1 times 1 times 1 times 2 squared. And of course, multiplying by 1 is, it doesn't change it. And so when everything is said and done, 2 to the 5th over 2 to the 3rd is equal to 2 squared. Now, what we would hope you'd start to notice is that you could get that 2 by simply subtracting the exponent. So 5 minus 3 would give you the 2. Now, normally I wouldn't write it out quite so much detail. So I might do something like this, okay, and engage the definition, and then simply say something like this. 2 over 2 cancels out, cancels out, cancels out. I just want to make sure that it's really clear why they're canceling out, and they're canceling out because something divided by itself is 1. That's the reason why they're canceling out. It's not something magical there. Okay, and they're also they cancel out as a whole because, again, it is all multiplication happening between these factors. And so you can see here that there's 2 2's left over. So you might be wondering, okay, well, that's great. It works with the 2. Does it work with other things? Why? Let's find out. So let's say you have a to the 6th over a squared. So that would be a used as a factor 6 times. 1, 2, 3, 4, 5, 6. Make sure I have the right number there. And just like 2 over 2 is 1, a over a is 1, provided a is not 0. And that's important to note, but it's also a safe assumption to make. 0 over 0 is the one exception to anything over itself is equal to 1. However, you know that a can't be 0 because that would have made the original problem 0 over 0, which means that it would be a moot point to start with. So if you're even being asked to simplify an expression like this, it is a fairly safe thing to assume. And then we have 1, 2, 3, 4 a's left over. And so this ends up being a to the 4th. And of course, 6 minus 2 would be a faster way of getting to that 4. So here is property number 3. And this is called the quotient of powers property. Again, as I said in the last video, I don't think it's super important that you know the names of the properties. And that says this: if you are dividing like bases, you can subtract the exponents. So as an example of this property being used, you might have 5 to the 4th over 5 to the 3rd, and so you would say, oh, that's going to be 5 to the 4 minus 3, which is 5 to the 1st power, which is just 5. Let's see. We've got like negative, oh, I don't want to give you that one. That's an issue of going out of order. Let's do x to the 8th over x to the 3rd. Well, good grief. That would be x to the 8 minus 3, or just x to the 5th. Okay, and this step right here, most of the time, most of us are going to skip it because we usually can do the subtraction in our heads. So you don't write it out. It's not bad to write it out, especially if this is a new skill and a new concept. It really is going to help reinforce that. Now, the other property that has to do with division has to do with this. So if you have A over B, and we'll just use a 3 to kind of establish what's happening. So this is like a fraction that's raised to a power. And of course, a fraction is division. And you can figure this out just like with all the others. If you understand what the exponent is, you can reason your way to this. So this means that you are taking the fraction A over B and you're using that as a factor 3 times. And so now that would be A times A, which is A to the 3rd, over B times B times B, which is B to the 3rd. And again, this only works for multiplication and division. And it really only works for division because if you think back to the early lessons, like division is multiplication. It's just multiplication by the reciprocal. And so that's why a lot of properties will come in pairs, and like it'll work for multiplication and division. So that's why it works. So I can do one more example just to kind of build the case here. If you have A over B and it's raised to the 4th power, that means A over B times A over B times A over B times A over B. And then, of course, to multiply your fractions, you just multiply across the top and the bottom. So A times A times A times A is A to the 4th over B to the 4th. And so here's the property. This is what, property number 5. And this is called the power of a quotient property. Power of a quotient property, and that pretty much says this: if you have a fraction raised to a power, that is the same as raising the numerator and denominator to that same power, and we do need to establish that b is not 0, so that which of course would make the original problem like impossible in the first place. So those are the 2 properties that have to do with your division properties, and they combine really nicely with the negative and the 0 exponents. It does kind of complicate what kind of practice problems I can give you here. So I'm going to give you a few practice problems, but this is really going to end up being a very, very short lesson, and then probably the next one will be a little bit longer because we'll bring a lot of the exponent things together. Okay, I don't think these will take too long for anybody to do, so I'll just, again, as usual, I'll read them off just to make sure that my handwriting is clear. So 2 over x all to the 4th, 6 to the 6th over 6 to the 4th, 3/4 all squared, 1/2 all squared. Number 4 that's actually something that you are fairly likely to see in some of your higher level math, so it's not a bad idea to look at it. 5 is 5 over 3 to the 3rd power. Number 6 is x to the 3rd times 1 over x squared, and 7 is 1 over x to the 6th power. As always, pause the video, take a moment, work these out on your own, and then unpause the video. Okay, so let's take a look at these. For the first one in red, I just applied the exponent to numerator and denominator, so it's 2 to the 4th over x to the 4th, or you might use the 2 to the 4th is equal to 16. Really just kind of use your best intuition or follow your teacher's directions on whether or not you need to change the 2 to the 4th over. For the second one, 6 to the 6th over 6 to the 4th is 6 to the 6th minus 4, which is 6 squared, or 36. For 3/4 squared, now I'm not sure why I just started doing these differently, but I just wrote, okay, well 3/4 squared is 3/4 times 3/4, and 3 times 3 is 9, and 4 times 4 is 16. So that would be 9 over 16. And I did the same thing with the 1/2. 1/2 times 1/2, well 1 times 1 is 1, and 2 times 2 is 4. And pause if you need to. And then for number 5, this one I did expand out. So we have like 5 over 3 times 5 over 3 times 5 over 3. 5 times 5 times 5 is 125. 3 times 3 times 3 is 27. You might also leave that as 5 to the 3rd over 3 to the 3rd. Okay, that would be fine as well. For number 6, essentially what I did there was I said, well, x to the 3rd is really like x to the 3rd over 1, and then multiplied straight across. So x to the 3rd times 1 is x to the 3rd, 1 times x squared is x squared, and then did 3 minus 2, which is x to the 1st, and then that's just equal to x. And so hopefully these went really smoothly. This was a very short lesson. The next one will probably be longer because we'll need to bring all of the properties together and explore a couple of new ones at the same time. So enjoy the short lesson while you have one.